All right, last but not least, maybe the coolest one of them is the centroid. Again, it's another version of the center of the circle. If I didn't say this before, right, we talk about measures of center in stats, right? Mean, median, and mode. Sometimes it's advantageous to talk about the mode of a data set, meaning the most frequently occurring data point. Sometimes we want to talk about the middle point in a data set, which would be the median. Sometimes we want to talk about the average. It would depend on the data set, which versions of those we want to talk about. Well, for triangles, we can have the circumcenter, which is a version of the center of a triangle. We can have the incenter, and then now we can have the centroid. And it just depends on what property we're looking at, what's important for us. So the centroid, let's draw this triangle first. Okay. And how do you find the centroid? Well, the centroid is going to be found by the medians. Right? Medians. The median is going to connect vertex to midpoint. Again, I'm going to eyeball these again. I'm going to take this vertex and I'm going to connect it to that midpoint. Let's say that midpoint is right about there. And I'll do my best. And I'm not even using a ruler. Okay, so that's one of the medians. And you're like, wait a second, what does even a median do? That's how you draw it. But it turns out that a median actually divides the triangle into two equal areas. These triangles right here, they're not exactly maybe the same dimensions, but they have the same area. And you can think about, well, it might be a little difficult if, you didn't have this conversation in class already, but it'll turn out that if this is the midpoint, then these are clearly the same size, definition of midpoint. So the base of the triangle is the same. And regardless, these two triangles have the same height. And that's actually, that red line is actually even fairly similar to what the height would be. But they have the same base and the same height. So they have to have the same area. That's what a median actually does. And let's draw this median. So midpoint maybe right there. We do that as the other median. There are three medians. And then we scoot over here. What do you think? Somewhere like there? And of course they intersect. So the centroid is right there. Okay, so the centroid, graphically, pretty easy to find. Just draw the three medians and the centroid is the intersection. So this is the intersection of the three medians. Okay, so finding the centroid is pretty easy. Just draw the three medians, find the midpoints, connect them, good to go. But it's got some really cool properties. So first, again, it's the intersection of three medians. Kind of boring. But it turns out that the centroid is the center of mass, or the center of gravity, which means it's the balance point. And so in class, you might have cut a triangle out of cardboard, drew the three medians, and then if you put your cardboard or your wood triangle and you put a pen right there, it would totally balance. The center of mass, well, if you put the pivot, meaning the balance point, right at the center of mass, then there actually is going to be no torque. I know we haven't really talked about torque, but you can just believe me that that's the right word. You're fully supporting, you're taking all of these things and condensing it down and pretending that all of the mass is right there at the center of mass. And so if you support the center of mass, you're going to be supporting the whole object and nothing will actually tip. It'll be totally balanced, right? Balance point, tipping point, center mass, all kind of indicating the same thing, which certainly is a very important physics engineering concept in terms of how would you find it for a weird shape like a triangle. And also, algebraically, it's pretty cool. It's actually also the average point. And what I mean by that is, it's the average point of the three vertices. So I'm just going to make up some numbers really quick. let's say this in a coordinate grid, this is like that, right? And so I'm just going to make these up. It's not to scale at all. So let's say this, I don't know, that looked like 4, comma 5. And this is, I don't know, what does that look like? 10, comma 12. And if that's 10 and that's 14, well, what's that guy? What do you think? 16? No. Yeah, let's make it 16. This is 16, comma, and if that's 5, that's probably not too much more than 5. Let's make that 8. 8? No. Let's make it 10. 10? No, it's not going to work out. I need it to be 5 plus 12 is 17. I really wanted to make it divisible by 3. So 4. Oh, we can make it 7. Sweet. Let's make it 7. Awesome. Okay, now it'll work out. Okay, so maybe kind of looks okay, right? 4 over 5 up, 16 over 7 up, and then 10 over 12 up. Okay, and so if I'm telling you that the centroid, if you put these 3 things on a grid and you did the medians, it's going to hit at the centroid, and the centroid is also the average point, and so we want to find that algebraically. We can just add them together. So x-wise, we can take 4 plus 10 plus 16, which is 30, and divide by 3, and we get an average of 10. Ooh, it's not going to look very good for that, but it is correct, right? That's 14, 16, 30, 10, and then y value of it, we just take the 3y values. 5, 12, 7, that's 24, and we get 8. So I'm telling you, if you put these 3 points on a grid, the centroid is going to be at 10, comma 8. Okay, and that's a coordinate. It is the center mass of that triangle. It's the balance point of that triangle. It's the average point of the 3 vertices. Again, the average of 3 numbers is just adding them up and dividing by 3. It is the intersection of the 3 medians, which is also cool. And then there's even some additional properties. Okay, the centroid actually divides each median into a 2-to-1 ratio. Okay, each median is divided by the centroid into a 2-to-1 ratio. And what that means is this distance is double that distance, 2-to-1. If that's 10, that's 5. If that's 12, that's 6. If that's 8, that's 4. If that's 6, that's 3. 2-to-1 ratio. Also, 2-to-1 ratio and 2-to-1 ratio. Right? There are 3 medians. The centroid is the intersection of them, and each one of them get divided into this ratio. You cool with that? So the centroid's got some physics engineering properties in that it's the center of mass, which is the balance point. It's easy to find algebraically. You don't even need a grid. But if you had a grid, you just draw the 3 medians, and it is the intersection point. And another cool part is that not only is it the center mass, but it happens to divide each of the medians into a 2-to-1 ratio, which you're going to be able to use in some problem-solving stuff. Okay, and that's centroids. Reviewing real quick, just because centroids was kind of the end here. The 3 main versions: centroid, circumcenter using perpendicular bisectors, Walmart, equidistant from the vertices, and then angle bisectors form the incenter, which is equidistant from the side. You have to be able to understand and draw all 3 of those pictures. You should review those. There's a PDF that has actually 4 of them on there. It even includes orthocenter, which isn't on the test. But certainly incenter, circumcenter, and centroid are all things you need to understand. And they each have their own little properties. They're each constructed in a different way. And you got to review them. Okay? Hopefully this helps.